All right, so we have successfully copied a segment. New challenge. You're going to sketch. I don't care if it's obtuse or acute. I'm always going to draw acute angles. They're all my angles roughly look the same no matter what the angle is because I don't draw to scale. I want you to sketch an angle. And again, this is all on our scratch paper. And in your notes, we'll just reference this and I'll share the pages with you to where you would find these actual steps. But I don't care that you can just do the steps. I want to see if you guys can work the steps out yourselves. Okay, a little harder problem. If I call this point B, if I say angle B, is it clear that we're all talking about the same angle? Yeah. Now, I could add more pieces to it, but last time we copied a segment, and it's not hard. What I want you to do this time is underneath, I'm going to put point C. I want you to copy this angle. You're not going to measure the angle using a protractor. I could, you're not going to. We're doing it without having the number of degrees. We don't care about the degrees. Using only these two, can you make me an exact copy of angle B such that it's congruent? That's the challenge. I'm going to give you guys a minute or two, and we'll see if we can pool our ideas together. Cool. Do it to it. I'm going to double check this in a minute. It's okay to be wrong. Yeah, try stuff. If it didn't work, good. And the sound in here, this is a harder problem. I'll get some tunes going. You guys are welcome to chat, just so you know. But we'll get some tunes going. I'll give you like 2 minutes. I want to see if anybody can come up with it. If we're here, I'm just going to go ahead and extend it straight out. Now, somewhere along this, I will find a new point, I think. What? All right, we'll try that again. Boom. There's a ray. Somewhere along here, there's a point. Now, could I add points here if I wanted? In fact, I do want to. I'm going to add this point. I don't even need to name it. But right now, I had a lot of people think to do the same thing. Step one. How can I ensure that I can find another point on this line that's the same? It's what we did before, right? So I'll go ahead and set my protractor. And if you guys haven't done this yet, it's awesome if you're paying attention. You should be paying attention. But I also want you to go ahead and do it. I have set this to the length of that new point, and I can copy that down to here. Anytime that you add stuff with a compass, here's what I want you to get in the habit of doing. You don't have to draw full circles, but I do want to see at least a portion of your circle. I can tell that this is a part of a larger circle. Okay, at this, I have now copied that length exactly, right? Now I don't really need the length, I just need somewhere to reference. Okay, everybody have something similar. Now, what people try to do, and it doesn't quite work, is if I extend this up further, which maybe I did, and I did here, you may try to eyeball it to ensure that we get the same spot. But there's an issue. If I draw it here, it's the correct length. It'd be the same length as the other one. Or if I draw it here, because the radius doesn't change. We can't only use that. Gosh, dang it. So what do I do? Hit it.
You can go from the point you made on the top one.
Okay.
And like go up until you choose your point, and then use the compass to.
Okay. So what I'm going to do, I have this already set, right? On your first one, I want you to draw this part of the circle. Use that same distance. Let's draw the same one down here. I have now identified this point. Okay. So here's my original. I have my compass set. I then draw a ray, and I use the same compass setting here. Now, I know that on this other angle, it's somewhere in here. Along this curve, it has to be, because I see that that's going to happen. Gosh. But let's change a little bit of distance. I don't know where up here it is, right? But I do know that this distance won't change. It won't change. It can't change. It's stuck. I've made sure that these points align correctly. If this is set here, and I'll do it a little bit more, I'll try to do the same arc. Those intersect right on that line, right? Or on that ray, I guess it's a segment right now. Gosh, well, I only need to go that far in distance. Did those two intersect? Now what? Hey, straight edge, don't need to measure. Boom. Now, Klein, you asked, this is kind of like an estimate. It depends on how precise you're being. We are likely not going to be exactly perfect, weird. But if I gave you just a straight ruler with no ticks on it, we're going to be closer with this angle than you would be if you just tried to eyeball it. Okay, if I wanted to use this to measure, do you guys know how? Okay, so we will take time to do this in the future, but I just want to verify. I'm going to measure. I can hold it however I want. I'm going to make this my 0. So I'm going to put the very center right here, and I will pay really careful attention to try to make sure that the 0 degree line is perfect in line with my side of the angle. Okay, I'm then going to count up until I get to this lovely segment. Mine looks like it's 40, because I'm going 0 to 10, 20, 30, 40 degrees. A little bit more than 40, right? So if I want to be real specific, and let me zoom in. Okay, so here's 40 degrees. It says 140 because we could go clockwise as well. So let's see, we at 40, 41, 42, 43, about 44 degrees. Everybody cool with that? Yeah. What do you think this next angle is going to be? If we did it right, it should be 44 degrees. Now, I'm going to extend it just to make sure I can see it. Let's check. I start at, you know what? We'll go crazy. I'll start here, and I'll move it so you can see it. I forgot I zoomed in. Okay, I moved it completely, right? Like I'm measuring from the other side. But I can still count up 0, 10, 20, 30, 40. I'm at 46. I have a small little error. Is it close enough that if I had taken a little bit more time and done so more carefully, do you think we could have been okay? Yeah. Yes, we can copy angles like this. Should we do one more? Yeah. Here's my challenge. Switch pages with your neighbor or nearest person for a second. I want you to copy their angle. Draw it on your page. Use your protractor settings. Set it. Copy your neighbor's angle. You'll each copy each other's. So you'll set your compass. And we'll see. I just want to verify that you guys can also do this. Cool. All right. Now, what I want you to notice, and we will do a bunch of these this year. So if you don't like it yet, good news is we get it all year long. The fact that that circle intersected those segments seems like maybe there's meaning to it. Okay, now, I have not touched my compass. I haven't changed any settings. This pin is just begging to be put down somewhere. I've tried it here. Where else might it want to be put down? Oh, well, that seems like a natural choice. We made a mark. Let's use it. Okay, I haven't changed my setting. I'm going to turn my page just so I can do it a little bit easier. If I put it right there, right at the intersection, it certainly doesn't look like it's super associated. That didn't really do anything, right? Well, dang it. Well, maybe this just wasn't the right point, or it just wasn't all of the points. If I swap this to here, and I haven't changed my size, is there a new point that's very obviously just waiting to be identified? It's this one, right? No, obviously not. What do you think is going to happen when I take this and I draw a ray through that? We have how many angles now up on the board?
2.
So there's at least 2. There's really 3, but there's 2 that we're focused on. And what do you think we would find if we measured angle alpha, there's a Greek letter, and angle beta? If we used this lovely thing to measure them, what do you think we're going to find? They are equal. We have successfully bisected an angle. Could we bisect each of these and then forsect an angle? Can you trisect an angle? If you want to, you certainly can. Absolutely you can. If you would like to borrow a compass and play around with trisecting an angle, I think that's awesome. You can. You can take one home. Bring it back. Don't stab anybody with it, but you can take it home. Cool. Hold on real quick. Miss Eustace walked in. What do we do? No, we don't say hi. We applaud. Good. Yes. Yep, new rosters. I don't have student contact info in there though. Cool. All right, baller. Okay, if you love this, awesome. I hope that it's fun. Fun. I don't know if this is fun or not. There's interesting mathematics hiding here that you've probably never thought about. You've never had to think about. I haven't always done these when I do geometry, but we're going to do them this year. I think it's more fun than just doing all the talking. Okay, we have a little bit to do from the other section. For now, I want you to set your protractors aside. We're going to use notes. We're not going to put any of this in our notes. I'll tell you in the book where are the directions for these, because they do have directions. I just didn't want you to see them. I want you to play around with the idea and do math like you're discovering it. Okay. So yesterday, we did that. We did homework, and I just collected your homework. Have we written any notes for 1.2? Oh, there they are, just this. Okay, cool. So, real quickly, if two angles are congruent, what does that mean? I'm going to hide that. So, if the angles are congruent, the measures are what? So equal is the word I'm looking for there. Same shape, same size for sure. But if angles are congruent, the measures are equal. If two segments are congruent, it means that the segments' lengths are what? So the lengths wouldn't be congruent. So it's weird language. Segments are congruent means the lengths are equal. The second you start to talk about something that you can measure with a number, we use equal instead. Okay, and I know it's so subtle and maybe you don't like it, but it happens. All right, we're going to continue on. We don't have a ton of notes to do. Okay, with congruence, we did the constructions. We'll add a little notes here. We have, gosh, the size of the screen is way off and it's bugging the heck out of me, but we're going to let it ride. Okay, within congruence, we are going to discuss these. When I write this, what do you think I'm referring to? The properties of, I'm going to write the word, what should you write instead of the word congruence? This. I would never write the word congruence in your notes ever again. I would always use this symbol. Same as I will never write the word angle again if I were you. Okay, there are three properties that work for congruence that we have to make sure we have locked in. We're going to see them over and over throughout the year, but these apply right away. You are going to recognize some of them. There's three of them that we're going to list. Two of them are nice and short to write. The third one is kind of ugly, so I'm going to do them as follows. The first one is called the reflexive property. Not reflective, but reflexive. The reflexive. Now, in your notes or in the book, it would say the reflexive property of congruence. I'm not going to write that whole statement. It's obviously a property of congruence. Okay, we have the reflexive property. We have the symmetric property. And these are both pretty short to write. The last one is a little bit longer, so I'll just do this one standalone down below. The transitive property. Now, the properties of congruence that we're looking at, you guys have seen before as properties of equality when you're just doing regular algebra. We have three properties up here. All I want to know is, of these three, how many of these words do you remember seeing? 0, 1, 2, or 3? So lots of ones, some zeros. Anybody remember all three of them? Okay, which one do you remember? Symmetric property. So you guys have certainly dealt with symmetry because you graphed parabolas, so it has something to do with that. Do you remember what the symmetric property is? I'm going to ask you a question. If I solve an equation and I get to the end and I write 5.2 equals x, does that bother anybody? Why? Like, I'm not wrong, but stylistically, I'm not quite the way that we would all do it. Say it again? So maybe alphabetical order, but in general, it's weird to think about alphabet with that. Normally, we would say x equals, right?
Yeah.
Is that any more wrong or right, though? No, symmetric property is this. You've used it your whole lives, but we default. Okay, I could do this with angles or segments. I'm going to do this one with an angle. If we have angle 1, and I tell you that it's congruent to angle 2, like maybe I just have two angles that happen to be congruent. If I tell you this, somebody remind me what this means? Implies. Okay, if you give me that angle 1 is congruent to 2, huge shocker coming up. Do you think it's also true that angle 2 is congruent to angle 1? It seems like so silly to write. It's true. This is symmetry. This is the symmetric property of congruence. Now, the same thing works with numbers. If x equals 5, then 5 equals x. Doesn't matter which way you write it. They're both the same. Same thing happens with congruence. I don't want to talk anymore about it if you guys are cool with that. Okay, for the reflexive property, this one, it's going to feel even sillier to write, and you'll wonder why on earth would you ever need it? We do need it, and we need it fairly often. Let's say I have segment AB. Right off the bat, have I even mentioned the existence of another segment in this? AB is the only segment I've ever mentioned. None others have to exist for this. What is segment AB congruent to? So BA, I agree with you. That feels kind of like symmetry, but you're right. Could I say it's the same as AB? Is a segment the same shape and size as itself? Yes, and it feels so silly to write, but the reflexive property is just that. AB is congruent to AB, or angle 1 is congruent to angle 1. You will always have that. I promise there's a reason for it. This is the one that I was expecting you guys to remember, to be honest. Oh, I gotta say, yeah, we don't even need anything else. Okay, this one, we are gonna learn some shorthand stuff, like real shorthand. I'm gonna use angles because they're shorter to write. Hypothetically, let's say that angle A is congruent to angle B. So we have two angles that are congruent right now. Now, I'm going to use the real symbol up here, and we'll use the words underneath. The real math shorthand for the word and is this. And. You don't have to write and. This symbol, just the capital A without the cross, it literally means and in any math book you'll ever find. So I'm going to claim that A is congruent to B. But more than that, I also am given that angle B is congruent to an angle C. A is congruent to B and B is congruent to C. Is there a natural logical conclusion that you're tempted to come to? Adeline says angle A is congruent to what if we link these together? C. This property is really, really common. You've used it in algebra. It's called the transitive property, or if you're a nerd and you study logic, it's called the law of syllogism is what it's called. We'll deal with it as when we get into logic stuff, we'll see that. But this is not a stretch, I don't think. Everybody cool with these? Yeah. All right, so we have like one example. And did I give first, third hour homework? You think I did? No. Ooh, we did not. Okay, here's the deal. I'm not going to give you guys homework tonight either. So long as you come to class tomorrow ready to work, with the understanding that instead of just saying we'll move forward, we're going to take a little bit more notes because we got another 90 seconds. I have a quiz ready for tomorrow if you guys don't work in class, just so you know. Cool. All right. One quick example to kind of leave you something to think about. All right. Let's check it out. We will jump in with this tomorrow, but I do want you to copy the figure. So this is my least favorite part of geometry. I actually kind of like the stuff that we study. I really do. But I hate copying pictures. You will learn to hate copying pictures. So let's get an example. We'll name it in a second, but I want everybody on the same page while we sketch it so we can do it all together at the same time. I'm going to drop down a bit. And I'm going to start right here with point A. I will go straight out to B. And I'll go up to C. A, B, C. We have a big angle there. Okay, beyond this, I'm going to shoot out two rays. We have Bravo Delta. They can be segments if you'd rather. Bravo Delta. We have Bravo Echo. Okay, I'm going to sneak a single arc across angle DBA. I'm going to put a single arc across angle EBC. And I'm going to write 32 degrees here. When you get to class tomorrow, I will have a couple more directions. Right away at the start, there's going to be our warm-up. You guys will start solving this problem. There's nothing for you to solve yet because I haven't told you what you're solving. But you guys have a wonderful afternoon. If you want to try to trisect an angle, take a compass. If you don't want to take a compass with you because you're not going to play with it at home, back in the box, please. Cool. Later Raiders, study hall is in here after school. Ronaldo, did you get a count? Did you get a count? Did you get a count?
I couldn't hear it.
That's fair. Okay.
I was waiting